this video lesson, we are going to take a look at trapezoids and kites. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called bases, and you can see kind of the labeling here. And then the non-parallel sides are called legs. So base angles would be kind of down here. They are formed by a base and a leg. And so A and B would be one pair of base angles, and then D and C would be another. Now, on an isosceles trapezoid, the legs would be congruent. So we can see three different properties down here for isosceles. And so we're going to go ahead and fill in the rest of the box for those properties. And that's going to say that each pair of base angles are congruent on an isosceles trapezoid. And then there is, if it has one pair of congruent base angles, then it is an isosceles trapezoid. And then the diagonals are congruent. If the diagonals are congruent, then it is an isosceles trapezoid, and if it is an isosceles trapezoid, then the base angles are congruent. You can go either directions because it's got that if and only if. So our next example down here is an isosceles trapezoid, as it says in the directions there. So we're going to go ahead and label all of our pieces here. This is a 3x plus 1.5 for Kn. And then KL up here is a 5x plus 1. LM is over here as a 6x minus 7.5. MN is a 4x. So the legs are congruent. So that would mean that we would be putting KN and LM equal to each other. And then solving. So if x is 3, it looks like we're trying to find angle M. Well, it's going to just be congruent to angle N, the other base angle. We don't actually know the values there. And then perimeter, we can plug the 3 back in to find all of our sides and add them up for the perimeter. So 4 times 3, that would mean 12 here. 5 times 3 is 15 plus 1 is 16 up there. 3 times 3 is 9, plus 1.5 is 10.5, and this is the same as that side, 10.5. So 10.5 plus 10.5 plus 12 plus 16 totals for a perimeter of 49. On this example here, it's already graphed for us, but we're going to go ahead and label. This would be A, this would be B, C, and D down there. So we're going to go ahead and find the slope for AD here. It is going down. It's like a slide. So a negative slope there for AD. We're going to go down 4 over 2, or down 2 over 1. If we want to reduce it, it's negative 2. And then we're going to count down 2 over 1 for that, so negative 2. So those are parallel. So we could go ahead and put our little arrows on there. And then for a B, we're going to go up 1 over 1, 2, 3, 4, 5. And then up, looks like 1, 2, 3 over 4, 3 over 4. Those are definitely not parallel. And so, is it a trapezoid? Well, we only need one pair of those opposite sides or bases parallel, and so it is a trapezoid. It's just not isosceles. So down here, we're going to find the measure of angle A. So it looks like this is an isosceles trapezoid because we have our legs congruent, so that would mean that these base angles are the same here. And since it's a four-sided figure, we would have a total of being 360. So we could also think of this as kind of like same side interior since we have parallel lines. So 100 here, this is going to total 180, so 80 here, and then this would be 80 since those base angles are the same. So a couple of different ways that you can find the measure of angle A is 80 degrees. Over here, taking a look at your diagonals, we have this diagonal MF as 32.7. We have KB, this little section, is 21.9. And so how would I find FB, this little section here? Well, it's going to be the same as this little section JB, and it's a part of this diagonal, which we know the whole diagonals on an isosceles, each diagonal, they're the same. So I just need to find this little section, but I know the total is going to have to be the same as this total, so 32.7 minus that long part is going to give me my short part, which is the same thing as FB. So subtracting to get 10.8. Down here we have an isosceles, since it tells us in the directions, so those base angles are congruent here. And so we're going to set an a squared plus 27 equal to a 2a squared minus 54. And then we're going to solve. Subtracting a squared, pretending like it's just an a, only it's an a squared, so we have 1a squared, and then we're going to add 54. And a squared is equal to 81. Now, this is the part where we want to undo what's squared by doing the square root. And so a is going to equal, square root of 81 is 9. Now, it's not only a positive 9, but we also have to account for a negative 9, because negative 9 times negative 9 is 81 as well. So we have two answers on that one when we take the square root. Over here on this one, we have diagonals congruent because it, again, says isosceles. So diagonals congruent for isosceles. So AD is this diagonal right there, and BC is this diagonal right there. So we're just going to go ahead and set those equal to each other to solve and make it into an isosceles. So 3x minus 11 is equal to negative 2, and we add 11, and 3x is equal to 9, which means when we divide by 3, x would need to be 3 in order for that to be an isosceles. Trapezoid midsegment theorem just says that if we were to want to find this middle segment xy, we would go ahead and add the top and the bottom, so BC plus AD, and then we would cut it in half, and that would give us the midsegment. So we're going to go ahead and add the 34 plus the 19, and then we're going to cut it in half, and that's going to give us the midsegment JF. And that is going to be 1/2 of 53, which is 26.5 for that one. Now what if we already have the midsegment? We know that 22 is going to equal 1/2 of 14.4 plus x. So we're going to work backwards, and we would either distribute the half, which kind of makes it a little bit messier. So instead of that, we can just multiply by its reciprocal 2, and that's going to cancel that fraction there. And we get 44 is equal to 14.4 plus x, and now we just have to subtract that 14.4. So x is going to equal 29.6. Last, we're going to talk about kites. Kites have a couple of properties here, and the first one is that there are two pair of consecutive congruent sides and perpendicular diagonals. So notice our tick marks here, and then I'm going to go ahead and put that little right angle symbol in there for our perpendicular diagonals, show they're perpendicular. So notice that the sides here, one right after the other, not opposite, but the ones right after each other, those are congruent. And then we also have congruent non-vertex angles. So right here. the ones that are not at the vertex there, those are congruent to each other. So let's go ahead and answer a couple of questions about some kites here. So again, we've got our right angle. So how would I find x, y? We would use Pythagorean theorem to find our c if this is my a and this is my b. So I would take my 8 squared plus my 24 squared, and I would set that equal to my xy squared. So combining 64 and 576, then I'm going to get 640, and I undo my squared by doing the square root. Use a different color here, show my square root. So xy is going to equal 25.3. And then for finding our yz, that length here, again, we have our right angle, so 6 and 8, and so those are our legs, and again, we're looking for our hypotenuse, so 6 squared plus 8 squared is going to equal wz squared. So 36 plus 64 is equal to wz squared, which is 100, and when we square root 100, we get 10. So doing a little bit of Pythagorean theorem there on those two. All right, back to some angles here. We've got 90, we've got 107, so what would this angle be here? Well, again, those are the ones opposite there. Those are 107, kind of at the wings. Not the front and the back, though, right? And so non-vertex. So angle A, we can figure out because we know the total is 360. So subtracting 107, 107, and then the 90. And that will leave us with 56 degrees, which is angle A. So here's kind of just the family tree. We can go to kite, we can go to parallelogram, we can go to trapezoid. Parallelogram, we know we can go to rhombus or rectangle, and then rhombus and rectangle both form this square. Our last page is just a kind of summary of all those properties. So I'm going to go ahead and kind of give you each one filled in, and then you can pause and write them down if you don't already have them. So here are those 5 properties for quadrilateral. Oh, as it kind of disappears, some of them. That's really weird. There we go. So opposite sides parallel, opposite sides congruent, opposite angles congruent, and then same side or consecutive are supplementary, and the diagonals bisect each other. Here are your properties for rectangle and rhombus. So again, go ahead and pause so that if you do not have those down, you can go ahead and get those down. And lastly, square.